Okay, so now we're going to do the last three. So we've done predicting what, or how to predict products if it's double replacement, because it produces a solid using solubility rules. We've done acid-base, which produces a liquid, water. And we've done single replacement, which produces a new element in a new compound by transferring electrons between element and compound and using the activity series. And we'll talk more about how that works, I think, when we get to redox. So the last one left is producing gases. And those tend to be synthesis, decomposition, and combustion reactions. And so again, you have to be able to classify them. All right, you have to be able to figure out what kind of reaction you're dealing with based on the reactants that are given, predict the products based on the type, and for most of the reactions, if it's a product that is a compound, you are going to drop and swap. And always remember, metals are written first, if there are metals. And then the last step, the very last thing, is balancing. Okay, don't make your life harder than it needs to be. So in a synthesis reaction, generally speaking, we have two small substances combined to make one bigger one. And you're going to use charges to determine the formula of the compound of most of the products. And then you balance the equation. So let me give you some examples. Na and Cl. I see element. That tells me this is synthesis. I'm going to drop and swap charges on Na and Cl. When I do that, I get NaCl. So the balanced equation is, put a 2 here and a 2 here. This one, again, element and element. I'm going to drop and swap charges. I'm going to get Al3 plus, S2 minus. So I got S plus Al goes to Al2, S3, 2, and 3. And now here, notice I gave you the name, okay? Because when you start getting nonmetals combining, I have to tell you what the product really is. And so when it says carbon monoxide, let's remember back to our naming rules. It means carbon 1, O, 1, or CO. So you got C plus O2 goes to CO, put a 2 and a 2. Okay, so synthesis isn't too bad. You have to recognize it. Decomposition is kind of the reverse of that. It breaks apart into two or more smaller substances. Most of the compounds decompose into the elements of which they are made. There are certainly lots of decomposition reactions that are more complex, but it's hard to predict the products unless you start just memorizing them. The big thing you want to watch out for is if any of these are your products, you better put a 2 afterwards. So, an example of decomposition would be Na2CO3. This one is one of those ones that does not break apart into the elements, and so Mrs. Packard would not necessarily expect you guys to be able to come up with this. What it does is it drives off a gas. Carbonates always drive off CO2. And then whatever is left over, you drop and swap. So Na and an O. Because there's 2 O's in here and 1 C, that means it's Na2O. I wouldn't expect you guys to do that. Maybe Miss Ellis and Mr. Lindenberger have different rules. That's my feeling. Now this one is just a simple compound, and it's going to break apart into the elements of which it is made. Do not do this. Okay, you need to recognize that this one is diatomic and so is this one. Then you balance it to account for the fact that it's the 3. It does not go from Ni3 into N plus I3. Okay, it breaks apart into the elements, and the elements as they exist in nature are nitrogen and iodine. This is actually a contact explosive. It will very easily decompose into this, which is a gas. Okay, MgO. When it breaks apart, again, it breaks apart into the elements of which it is made. Mg exists as Mg, but oxygen doesn't, so you need to put a 2 there and a 2 there. Okay, Al2S3 breaks apart into Al and S. This is just the reverse of the one we did on a previous slide. 2 Als and 3 S's. Neither one of those exists in a diatomic nature. Okay. Combustion reactions, these are easily confused with single replacement because technically you have an element, hydrogen, oxygen, and you have a compound that's called a hydrocarbon. You have to learn to recognize them. There's no other way to tell you. I mean, you just have to. And they always produce CO2 and water. So, for example, butane, if you've ever lit a lighter, if butane is ignited, you got C4H10 plus oxygen goes to CO2 and H2O. I recognize this as being a hydrocarbon, And if it says ignited, that means it's burning an oxygen. Then you balance it, put a 4 and a 5. Oops, that gives me an odd number. Double everything. And then you have 16 and 10. Put a 13 here. Okay. Sample of C6H12O6. This is sugar. This is what happens when you digest sugars and your body uses them for fuel. It's burned. Produces what happened there? CO2 and H2O. Again, a 6 and a 6 and a 9. Balancing is the last thing. So, determine the type of reaction based on the reactants, predict the products, and balance is last. So now, I want you to look at them and see if you can figure it out. All right, I'm looking at this one. I see one compound all by itself. Tells me decomposition. It's going to break apart into the elements of which it is made, both of which are diatomic. So put a 2 and a 3. This one, I see an element. Tells me synthesis. Drop and swap charges. Ca is positive 2, phosphorus is negative 3. And again, balance afterwards. Then I see hydrocarbon and oxygen. Could also be written this way. Doesn't matter. Hydrocarbon and oxygen tells me combustion. CO2 and H2O. Put a 5 and a 6 and an 8.